Welcome back, folks. In today's class, I'll talk about how you can find out the acceleration, velocity, and displacement from the from using formulas and using the graphs. That's what we will learn in today's class. And then we will also look into some of the basic kinematic equations. So first of all, I'll try and draw the graphs. So if you are given the displacement time graph, this is the displacement time graph if given to you, displacement time graph. So this is how your velocity time graph will look like. So if you don't know how did I draw this velocity time graph, you can watch my previous video in that I've explained how you're going to get the velocity time graph if the displacement time graph looks like this. So then if this is the velocity time graph, then the acceleration time graph will look like this horizontal line. Now, I wanted to find out the velocity. Let's say displacement values is given to me and I wanted to find the velocity. So I will use the formula. So formula is d final minus d initial divided by time. That is the velocity average. That's how we're going to find out. Now, if you are given the velocity, now if this velocity is given and this final velocity is given to you and you are asked to find out the acceleration, then you will use the formula. Acceleration is equal to velocity final minus velocity initial divided by time. Again, this will be an average acceleration. So notice if you carefully notice this, then you'll find that you are moving from the displacement to the velocity, and then you are moving from the velocity to the acceleration. You are moving in the forward direction. Now, if you have to move in the opposite direction, which means if you are moving from acceleration towards the velocity, or you are moving from velocity to the displacement, then you will use the area under the graph. So what do I mean by that? So for example, if I were to ask to find the velocity and I've been provided with the values of acceleration, so I will use the formula. There won't be any formula. I'll just make a formula from the looking at the graph. So what is the area of this graph? That is the height times the width. So that will be equal to, this becomes the height and this becomes the width of the graph. So a times t, that will be the velocity if I'm trying to find the velocity using the acceleration time graph. And then same way, if we are trying to find out the displacement using the velocity time graph, I'll again use the area under the graph of velocity time. So this is the area under the graph. This becomes a right angle triangle. So I will use the displacement will be equal to half times height times time. So height will become, in this case, that is the velocity. So this is half times velocity times time. That's how you can find the displacement. So again, if you are moving in the forward direction, then you will use the formulas. These formulas: velocity average equal to d final minus d initial divided by time, and velocity average acceleration average is equal to v final minus v initial divided by time. If you are moving in the opposite direction, means you are given the acceleration, you are trying to find the velocity, then you will use area under the graph. That's the technique you will use. So hopefully you are now you understand that how you're going to solve the problems when you are given the graphs or when you are given some values. So now I'm going to go to the next topic, that is the basic equations of the kinematics. Equations of kinematics. That's what will talk about. Now, the five parameters we've talked about, one was velocity initial, another was velocity final, and then we also talked about acceleration, and then we talked about a displacement, change in displacement, delta D, and the time. These are the five parameters, and using these five parameters, we can drive out the five equations. One of the equation is velocity final minus velocity initial divided by time, that is equal to acceleration. Another equation is delta D is equal to, delta D means the change in displacement, so V final plus V initial divided by 2 multiplied by time. And then the next equation is delta D is equal to VIT plus half AT square. And then the next equation is delta D equal to V final times time minus half AT square. And then there is one more. actually v final square equal to v initial square plus 2a delta d. These will be given to you in your formula booklets, or I'm pretty sure these equations will be there provided uh, in your formula booklet by your examiner. So these are the 5 equations. So 1, 2, 3, 4, 5. If I see, these 5 equations have been built by using these 5 parameters. Now the students find it really confusing when to use which equation. So I'll tell you right now how to use the equations. In any questions, you will be given 3 parameters and you will be asked to find the fourth parameter. What do I mean by that? So if you are given initial velocity, velocity final, and time is given to you, and you are asked to find the displacement, and these 3 are given to me, and I've been asked to find this one. How I'm going to find out this delta D? So which parameter, I'll first of all try and see which parameter this question is not talking about. This question is not talking about the acceleration. So if we're not talking about the acceleration, so I will skip all the equations which has acceleration into it. I'll skip skip this equation, and then I will skip this equation too. I will skip this equation too. I'm left with this equation. I'll use this equation. That's how we can select an equation. Now I'm going to try and solve one question based on whatever we've learned. So for example, if there is a car which starts from rest and accelerates to a final velocity of 10 meters per second. This is given to me, and to accelerate to 10 meters per second, it takes 3 seconds. For the sake of simple calculation, I'll keep it as 2 seconds. 2 seconds. From rest to 10 meters per second, it takes 2 seconds. I wanted to find out what is the acceleration of that car is. That's what I wanted to find out. So I'll see which parameters are given to me first of all. It starts from the rest. It means initial velocity is equal to 0, and it reaches to a final velocity of 10 meters per second. Velocity final is 10 meters per second, and then it takes the time 2 seconds. So time is given 2 seconds. I've been asked to find out the displacement delta D. So 3 parameters are given to me, and I've been asked to find the fourth one. So let's see which equation I can use. I will first of all, I'll look into which equations I can skip. So I'll skip all those equations which has acceleration uh, into, well, I've been asked to find, sorry, my apologies, I've been asked to find the acceleration, not the displacement. This is what I've been asked to. Acceleration is what we're looking for. So I'll skip all the equation which has displacement into it. So displacement equations, this is what I'll skip. This is what I'll skip. This is what I will skip. This is what I'll skip. I'll use the first equation, V final minus v initial divided by time, and that is equal to acceleration. And then this will be final is 10, initial is 0, time is 2 seconds, so acceleration value will come out to be a is 10 divided by 2, which is 5 meters per second square. That's the acceleration value. Again, I haven't given the direction, so in the exam you will be given the direction, so make sure you do take the direction. One more time, if the object is moving in the east direction, oops, my apologies, guys. If the object is moving in the east direction, this is positive. If it is moving north, positive. If it is moving west, it is negative. If it is moving south, this is negative. That's how we can take the direction. Now, I'm going to take another question. Let's say this is a cliff. You're standing on top of a cliff. Now I'm moving everything on the vertical direction. You're standing on top of the cliff and you throw something from this cliff in the downward direction. And when you're throwing something in the downward direction, and the word will be used something like drop. The drop in scientific language means you are not providing any initial velocity. So V initial will be equal to 0. So while we'll be solving these kind of a question, we need to be very careful with the kind of a wording given to us. So if the word used is drop, it means no initial velocity. And we wanted to find out with what velocity it will strike the ground. Or this case, rather than finding the final velocity, let's say I've been asked to find out the height of this cliff. That's what I wanted to find out. So what I'm going to do is I'll see what else is given to me. I've been, let's say it takes 3 seconds to reach to the ground. 3 seconds. So you the the stone is being dropped. So initial velocity is 0. Time is given to me 3 seconds. And then nothing else is given to me. If nothing else is given to me, then I'm stuck because I have only two parameters. As I said earlier, I need minimum of three parameters. So if I see the question carefully, it says the object is moving downward. Why the object is moving downward? Why it is, if you're just dropping it, you're not providing any force, why it will move down? Because the gravity. So acceleration in the vertical direction will become gravity, and gravity value will always be 9.81 meters per second square, always negative. Whether you are standing on the ground, you are throwing something in air, or whether you are standing on top of a cliff and you're throwing something in the downward direction, acceleration due to gravity will always be negative number. So G value is negative 9.81 meters per second square. As long as you are on Earth, then this is the magnitude you will consider. If you are on Mars surface, you will consider the mass. Mass G value is 3.61. And again, that will also be negative because acceleration due to gravity will always be taken as a negative in kinematic equations. So now I wanted to find the delta D value. Now I have three parameters given to me. I'll encourage you guys to pause the video and try to find the answer for this. So welcome back, folks. Now delta D is what we are looking for. So delta D is what we trying to find. So I will first of all look into the equations, which equation we can skip. We will skip all those equations which has final velocity into it. So this equation will be skipped, this equation will be skipped, then this equation will be thrown away, this will also be thrown away. I'll use this equation. Third equation will be used by me. So delta D value will be equal to velocity initial times time plus half gt square. This is initial velocity is 0. 0 times time is 3 seconds. This is where students make a mistake. Sometimes they end up writing it 0 times time, 0 times 3 as 3. That is wrong. So 0 times anything is 0, plus half times negative 9.81 times 3 square. And then this will give me, if I do the math, half this reduces to negative 4.905 multiplied by 9. So if I do the calculation, that should come across as 4.905 multiplied by 9. It is 44. So this is negative 44.145. That is delta D. So negative means the object is moving in the downward direction, and that's what's going on in the question. The object is thrown from a cliff and it is moving in the downward direction. So that is the displacement you're going to calculate. So hopefully you understood how to use the equation. So again, it's very simple. In all these equations, the equations which I've written down here, these 5 equations, if the object is moving in the vertical direction, A will be replaced with G. Here it is A, this will become G, and in this equation A will become G, A will become G, A will become G, A will become, yeah, pretty much that's about it. So, and G value is, as I said, negative 9.81 meters per second square in kinematics. All right, hopefully you were able to understand this concept, and I'll see you with some more examples in the next video. Until then, if you think of subscribing, that'll be great. Otherwise, have a good day. Bye now.